Hello everyone and welcome. So we are continuing on the unit coordinate geometry, and our topic today is lines on the Cartesian plane. We want to be able to define a line algebraically. So in the previous lesson you saw where a line or a line segment could be drawn on the Cartesian plane given at least 2 points on that line. Now we're going to look at something different. A line can also be drawn on the Cartesian plane given its algebraic equation. The algebraic equation that defines a line is called a linear equation. And as you can see the word line appearing in linear here. Below, we have a commonly used form of the linear equation where we have y equal mx plus c. Or in the USA or other regions, they have y equal mx plus b. So you can pause the video here and take up this section of the notes and we move on to the next section. Alright, so what does this linear equation in this form that we call the slope-intercept form, what does it stand for? If you go on mathisfun.com, you will see a very good explanation of what the equation stands for. For this level, we will only point out that in the equation, the m is some real number that represents how steep the line is. In other words, it represents the slope, the gradient, or slantness of the line. And the c value will represent the value of y when x is equal to 0. For example, in the image here, the c value is 1, right? It tells you where the line cuts the y-axis. And as you can see, it cuts the y-axis at the point 1. And at that point, x is equal to 0. The value of m will tell you how steep the line is. But that is for further lessons. Now let's look at some examples of linear equations. So here we have an example, y equal 2x plus 1. So as you can see, the gradient is 2 and where the line cuts the y-axis is at the point 1 for y, while the x value will be 0. There are other forms of linear equations or other ways of writing linear equations. For example, we have linear equations where we only have one variable, like x being equal to some real number. In this case, we have x equal to 1. Or we have y equal to some number. In this case, we have y equal to 2. Or we can even have y being equal to x in some form of combination. Also, on mathisfun.com, you can find this added piece of information about what we use to identify a linear equation. So you can pause the video here, take off the notes that you're seeing so far. So there are many other ways of writing linear equations, but they must have simple variables like x or y. In other words, the variables like x or y should not have exponents, or they do not have exponents in linear equations, and they do not have roots like square roots, cube roots, and so on. For example, these are equations that are not linear equations. So you can pause the video here, write off that part of the notes, and ask yourself, why are these not linear equations? Alright, ready for the answer? These are not linear equations because, as we said, the variable should not have any powers, and this y has a power of 2. The variable should not have any roots. This x has a root, and this x has a power. So these are not linear equations. However, these are linear equations. So you can pause the video here and write these examples of linear equations. As you notice, not all of them are in the form y equal mx plus c. Only the first one is in that form currently. Alright, so that is it for this section of the video. We will move on to the next section where we will try to see how can we plot a line on the Cartesian plane using these equations. See you then.